Hello, my name is Fidon, and in today's video I will talk about automatic fetal brain 3D MRI segmentation. The current state of the art for fetal brain segmentation is deep learning, and deep learning needs a lot of manually segmented fetal brain MRI to be trained. Here is how training a deep neural network works. At each training iteration, we draw a batch of pairs of 3D MRI and manual segmentation. The deep neural network computes an automatic segmentation for each 3D MRI, and the automatic segmentation is compared against the manual segmentation using a loss function. This comparison gives us a gradient that is used to update the parameters of the deep neural network. We repeat iteratively until convergence. Unfortunately, in practice it is difficult to find clinicians with the skills and the time required to annotate hundreds of images. And one typically ends up with many images that are partially segmented. That is, images for which some, but not all regions of interest were manually segmented. In this work, we propose a generalization of the loss functions that can be used for segmentation. Here are our contributions to this problem. First, we propose an axiomatic definition of the loss functions for partially supervised learning, that we call the label set loss function. Second, we propose a method to convert existing loss functions into label set loss functions, and we prove the unicity of this conversion method. Third, we propose the leaf dice loss function, that is a specific label set loss function. And finally, we evaluate different loss functions for fetal brain 3D MRI segmentation using partial segmentations. The underlying question for defining a segmentation loss function is what is an error at the voxel level? In partially supervised learning, there are two types of voxels. First, the annotated voxels, like in fully supervised learning. In this case, every tissue type except the known true tissue type is an error. Second, the non-annotated voxels, and this is what is specific to partially supervised learning. In this case, the true tissue type is unknown, and we argue that any tissue type that was not annotated in the image should be accepted. So this is the essence of the axiom that we propose in this paper. We call label set loss functions the loss function that complies with our axiom. For more information about our theoretical contributions, we invite you to check our paper. We have used a dataset with a minority of fully segmented MRI and a majority of partially segmented MRI. We have compared the proposed leaf dice label set loss function to three baselines for the problem of fetal brain 3D MRI parcellation using partially segmented training data. You can find the quantitative evaluation with dice score and Hausdorff distance in our paper. We found that the proposed leaf dice label set loss function outperformed three other baselines for fetal brain segmentation. In conclusion, don't worry if not all the regions of interest are segmented in all your images. Be happy with partially segmented images.